Hello friends, my name is Mr. Dhawale, Department of Chemistry, RBNB College, Sri Rampur. In today's topic, we are going to learn about third law of thermodynamics. Okay. In previous lecture, we already discussed regarding first law, second law. In case of first law of thermodynamics, that law is concerned with the conservation of energy. Okay, if we go through the first law, at that time it gives different type of statements. Okay, in that case, energy cannot be neither be created nor be destroyed. It can convert one form to another form. Okay. Then another statement of first law is if we take an isolated system, at that time we say energy of an isolated system or total energy of an isolated system remains constant. Okay. If we take an isolated system, at that time you say here that isolated system is not in contact with the surrounding, or there is no any connection with the surrounding to the system, so that there is no any gain of energy and there is no any exchange of matter, so that its total energy of an isolated system remains constant. Then another statement of first law of thermodynamics is when we take an there is no any such type of machine which can work efficiently or which can work with 100% efficiency. Okay, so these are some statement of first law of thermodynamics. Then when we go for second law of thermodynamics, at that time in this case second law of thermodynamics is totally concerned with the spontaneity. Okay, so spontaneous processes are totally included in second law of thermodynamics. And in case of second law of thermodynamics, there is no any utilization of energy when that process is spontaneous. At that time we take some example like when a rolling ball from the higher level to the lower level, then flow of water. If you take an example of river, at that time you say here the water flow in the river which is spontaneous. Okay, flow of air from higher pressure to the lower pressure, this is also a spontaneous process. Okay, so these type of examples are also included in that section. Then we go for third law of thermodynamics. In case of third law of thermodynamics, third law of thermodynamics. So what is the third law of thermodynamics? So first you say it's a statement we write here: the entropy of all perfectly crystalline solids entropy of all perfectly crystalline solids may be taken as zero at the absolute, may be taken zero at absolute zero temperature. So this is the simple definition regarding this third law. Okay, and means what this third law of thermodynamics is concerned with the entropy of a system. Okay, concerned with entropy of a system. Okay, so the entropy of all the perfectly crystalline solids may be taken as 0 at absolute 0 temperature. Okay, here some words which may be understood in this case. Here, if we say perfectly crystalline solid, so first you know what is the meaning of perfectly crystalline solid. So perfectly crystalline solid means that if the atoms present in the crystal which are arranged perfectly, okay, in the ordered manner, okay, at that time we call that crystal may be perfect crystal. Okay, but I think there is no any crystal which is perfect, which one comes from the nature and which is naturally synthesized. At that time, here we assume that if the solid is perfectly crystalline at 0 degree Celsius or 0 degree temperature, its entropy is assumed as 0. Okay, so here we write entropy symbol is S, and at 0 temperature we write here S0 is equal to 0. Means what? Entropy at 0 temperature of perfectly crystalline solid, it is 0 and it is considered as 0. After all, we consider all those things, means what? These are some postulates. Okay, and here the another word which is entropy. So what is the meaning of entropy? Entropy is nothing but the measurement of disorder. So first we see here entropy means measurement of disorder. Okay, so what is the meaning of disorder? And you say generally we make some statements like this: entropy of the universe is always going on increasing. So here, if we change ordered arrangement into the disordered arrangement, at that time entropy of that system will increases. Okay, suppose you take an example like a glass vessel. If that glass vessel is in good condition, at that time we say entropy of that glass vessel is very less. When we thrown that glass vessel from the higher level, at that time it will break into some pieces, broken pieces, and at that time we say the entropy of that system will increases. Why? Because the ordered arrangement will becomes converted into the disordered arrangement. So in universe also such a type of things are seen. Okay, and which are continuously going on, so that entropy of a universe always increasing. And this is one of the perfect statement about third law of thermodynamics. And now you say here entropy of a system of perfectly crystalline body is 0 at 0 temperature. Then next, what are the importance of third law? So here we write importance of third law of thermodynamics. So what are the importance? So first importance is calculation of absolute entropies. calculation of absolute entropies. When we take any system at that time, or if you want to check its entropy at that time, you use such type of formula, equations, to calculate the absolute entropy of a system. So here we consider the entropy change in a small manner, and we call that it's nothing but the infinitesimal change in entropy, how we can calculate. So there's some equation, ds is the small change in entropy is equal to dq upon t, dq upon t. But here we know Cp is equal to dq upon dt. Cp is equal to dq upon dt. Okay, so here we write, or we write here dq is equal to Cp dt. Okay, so this is the value we have for the dq, and when we replace that value Cp dt by dq by Cp dt, then after the putting the value Cp dt in this first equation, at that time we get some changed equation like this, Cp dt divided by t. Okay, so this is the equation used for the calculation of absolute entropy, and here Cp is nothing but the heat capacity of a system, then T is the temperature at which we can carry out that entropy calculation, and this is the change in entropy. Okay, so this is the simplest example, and when we want to calculate at the different temperatures entropy at different temperatures, at that time we want to integrate them, and the integration is from 0 temperature to the temperature at which we want to calculate the entropy. So here the change in that equation is somewhat like this. Here S is equal to S0 when it can be taken as 0, and S is equal to ST. ST means what? At the T temperature, entropy at T temperature. Then next ds is equal to T is equal to T, and S is equal to T is equal to 0. Okay, Cp dt upon T, and that equation we also write like this: S minus S0 is equal to T 0 to T Cp dt upon T. Okay, so in this two manner we try to write here in integrated format. Then if we take that crystal is perfectly ordered, at that time S minus S0, or here ST minus S0 means what? The crystal is perfectly ordered or perfect crystal, at that time S0 is equal to 0. Why? Because at 0 temperature entropy of a system is 0. So when we put that value S0 is equal to 0 in this equation, at that time we got here the different value, and that value is nothing but the ST is equal to 0 to T Cp dt upon T, and also it can be written like this: ST is equal to 0 to T Cp d ln T. Okay, in both format we write like this. So these are the equations we use for the calculation of entropy. Okay, then It can also be shown in the graphical format when heat capacity versus temperature in Kelvin. When we plot that graph, at that time we have some idea about at which temperature what is the entropy of that system, and so on. Okay. So these are all about the third law of thermodynamics and how we can use the third law of thermodynamics for the calculation of some systems. And here that system is in solid format. If we take that in liquid and gaseous form, at that time it have a different equations we use for the calculation. Okay, thank you.